my fellow assassins, to another episode of the Dark Assassins podcast, the show that dives deep into not just technology, but the concepts, software, and procedures behind it all, and explains it so simply that even your grandma can understand it. As always, I'm your host, the Dark Assassin. So welcome back to another weekend, my fellow assassins. I'm not sure about you guys, but I had quite the busy week. I was being an absolute code monkey essentially all week, as we will discuss later on in the episode. But if you follow the Dark Assassins Inc. Facebook or LinkedIn pages, you probably already knew that. Also, if you listen to this podcast frequently, one of the projects that all the code that I did this week, you'll be well familiar with. But before we get into that, let's get into our trivia question for the week. So this week's trivia question is when was the first multi-core processor introduced? So essentially, what year was the first CPU with more than one core introduced? That, and bonus points if you can guess either the brand or the architecture or anything like that. So you get bonus points if you can get any of those. Now, before we get into our cybersecurity tip, do you guys remember my my router saga that I had like a few months ago? So So this week, I was watching a movie. I was watching Tron Legacy, which, by the way, totally underrated movie, by the way. Excellent soundtrack, fantastic movie. But for whatever reason, so the reason why this is an issue is because I was streaming it from my Jellyfin server, and my Jellyfin server obviously is on my server network, and my TV is obviously not on my server network, so I had to go through my router to get to the Jellyfin server, and the stream just like cut out on me, and I was like, that's weird. I guess the router died again. But yes, the router died on me again, but the whole computer died on me. Like, the entire computer just, like, completely crashed. Like, Proxmox, the hypervisor that's running my router and a Pi-hole instance on there, it just crashed. I don't know why. That's not the first time it's happened either. So this box might be on the fritz here. But one thing I wanted to get back to was the fact that it was Tron Legacy. Now, that might not sound like what the heck, why are you talking about Tron Legacy? This is a technology, software development, home lab show, not a movie review podcast, which you're right. But I'm going to try to tie it all in and make it make sense here. So if you're unfamiliar with the premise of Tron and Tron Legacy, kind of the idea is it's this sci-fi future. Well, it's not really futuristic since it's supposed to take place in present day, but it's like this sci-fi thing where this guy, Kevin Flynn, essentially makes his own like digital world. And I gotta say I'm pretty sure, like, if I think back to some of the things that inspired me to be a software developer, I think I have to put Tron Legacy up there as one of the things that inspired me, since there's a few things that kind of stick out to me that made me kind of want to get into software development. One of them was back in high school. One of my friends showed me how to make like pop-up message boxes on Windows, and I thought that was like the coolest thing in the world at the time. So I was learning how to do that and make pop-up message boxes. And then I kind of got into learning how to make like batch files that can like do super basic things, and then like super, super basic websites, but like terrible websites that was literally just raw HTML, and it was bad, but you got to start somewhere, right? But I think another one that sticks out to me is definitely the Tron Legacy movie, because this idea that you can program an entire simulated world, like an entire ecosystem, an entire world, and you can do that in code, just sounded so darn cool to me. And I was like, man, I want to be able to do that someday. Obviously, I haven't been able to do that. One, because I'm not smart enough. Two, I'm not sure if it's even possible, but then again, that might be because of reason number one. And also, as far as being teleported into said world, I'm pretty sure any physicists out there can correct me if I'm wrong, but I'm pretty sure there is no like quantum teleportation technology, at least that I'm aware of, that would allow you to be transported into a computer program like that. I don't believe that exists. Now, if it does, I would be more than happy to be proven wrong. And informed of said technology, but I don't believe it exists. But the other, I guess, the final reason why I won't be able to make a simulated world like that, is because, quite honestly, I do not have the time. You guys are well aware of all of the many projects that I have, personal project-wise, many of which get neglected. Although, as we'll get into this week, I did knock 2 of them out, so that's pretty good, I think. But this would definitely, obviously, be a major undertaking, since it would essentially be like programming your own operating system plus some, essentially. Because if you've seen the movie Tron Legacy, or even the original Tron for that matter, you know that like the users, or the actual humans, specifically Kevin Flynn, the guy that made it, has like the ability to manipulate things inside the grid. So you could kind of think of the grid as essentially its own operating system running on a server, computer, wherever the heck it's running. And then all the individual programs are like, kind of like programs running on an operating system. So having to program all that, I mean, you're talking easily in the millions, probably, lines worth of code, like millions of lines of code, probably. And that's probably like an easy guess. And I do not have the time for that. Now, I think it would be awesome, and it's like one of those things that like I kind of really want to do. And every time I see that movie, I kind of get this new energy to start it and do it. But then I think of how big of a task it would be. I have no idea where to start. Well, I mean, I kind of have some ideas where I would start, but at the same time, like, it'd be one of those projects where I'd be really into it and then get a decent, some progress made on it, and then some other project would come along and I'd get sidetracked, and then that project would just get neglected, and maybe until I watched the movie again. I don't know. But yeah, I just thought that was something interesting to share. By the way, if you have not seen Tron Legacy, I know like review wise and stuff, it didn't necessarily do all that great, but I think it's a fantastic movie and definitely underrated in my opinion. So with all that out of the way, let's get into this week's cybersecurity tip. So this week's cybersecurity tip, this is kind of something that I've touched on a couple times in the past, and this is the fact that you should have a firewall, a good strong firewall, but not just one firewall, multiple firewalls. And the reason I say multiple firewalls is because your router should have a firewall on it. And any devices that you have, like laptops, phones, tablets, all those should theoretically have firewalls on them. I know all the operating systems like Mac OS, Linux, Windows, all those have built-in firewalls on them, and you should definitely be taking advantage of them. And the reason for this is the more layers of security you have, the safer you'll be, because while they might be able to get through the attackers might be able to get through one layer, if you have multiple layers of defense, that's that many more steps standing in their way to wreck you, essentially. And when it comes to firewalls, don't be opening up all the ports. Make sure all of your ports are locked down unless you actually have a need to use them. And if you do have a port open, make sure whatever system that is utilizing that port is one, secure, potentially segmented off from the rest of your network, and it's just something you want to be careful about, because if you have, say, like a web server running at your house, which probably don't want to be doing that, but I mean, you do you. If you have a web server running at your house, if the web server potentially has a vulnerability in it, an attacker could get in through your web server and then get into the rest of your network and do whatever they want. So if you had, say, it segmented off like on its own VLAN where it can't talk to the rest of your network, then there's not as much to worry about. But you just want to make sure that if you are opening ports on your firewall, you take the necessary precautions to make sure that if an attacker does get in, they don't have the ability to do as much lateral movement and get around your network. I know for me personally, the only port that I have accessible to the broader internet is for my VPN access, and the only way that you can get in through my VPN is if you have the certificate from one of the users, which the only way you can get that certificate is if you are already on my home network and navigated to the VPN and logged in as one of the users and downloaded the certificate. So I personally feel pretty confident that I won't get hacked. Plus, I don't broadcast my IP address to the public, which is another good thing, which I guess that could be cybersecurity tip number 2. Don't broadcast your public IP to everyone in the world. Now, you could use a VPN for this. There's a couple ways to do it, but like, for example, if you're especially if you're like a developer or anything where you're working with IP addresses, if you're ever working with IP addresses and you're planning on making that work public, make sure you either mask the IP addresses or like blur part of them out, or if you're like uploading source code or something with IP addresses in them, change them. Don't use your actual IP addresses, especially your global IP address, because if you expose your global IP address, that could allow attackers to launch a distributed denial of service attack, and then you won't have internet and you won't be having a fun time. So yeah, that is your cybersecurity tip for the week. Now, before we get into all the crazy wild coding I was doing this week, there's one thing I do want to address, which is a question that I got from one of you fellow assassins, which is, how do QR codes work? Now, I think this is a good question because a lot of the time, like, we kind of take QR codes for granted, I think. It's like that thing where it's, it's the square and has a bunch of pixelated dots, and then you point your phone's camera at it, and then, like, a website pops up, and it's pretty cool how that works. So, what are QR codes? So what it all boils down to is a QR code is essentially just a barcode, like any other barcode you'd find on like so anything that you'd buy at the store, right? So on any kind of like grocery item or anything that you could get at like a Walmart or a Target or Dollar General, literally any store, pretty much any item sold has a barcode on it. And literally the whole point of the barcode is to encode information about the item. So in the case of like items that you buy at the store, it, has like what the item is, so that when you scan that barcode, the system can tell what item it is, and then it knows how much to charge you for said item. So in a nutshell, that's really all a QR code is, but how it goes about encoding that data is different than normal barcodes, because normal barcodes just have a bunch of straight lines up and down, and the only really difference is their thickness in the lines. But QR codes are different, because QR codes rather than basically being one-dimensional, which is just vertical lines and the only difference is their thickness, QR codes are really two-dimensional, where they're a bunch of squares, and the squares can vary in size. So basically how the data is encoded is based on where those squares are in the QR code, how big they are, and all that kind of determines what the data is and how it's encoded. So the first thing that you'll notice when you look at QR codes that stand out right away are those three big square things on the bottom left, upper left, and upper right corners of the QR code. And basically what the point of those are for is to help whatever QR code scanner you're using, in most cases probably your phone's camera. It basically helps it align to where the QR code is, so it can properly line itself up to be able to decode the data. So that's why when you point at your phone at like a QR code, it kind of like has that thing that kind of looks like it's scanning it a little bit, and the URL or whatever doesn't pop up immediately, because what the camera has to do is focus in on those essentially three points to align itself, and then it's able to decode the data that way. So that's probably the biggest thing. That's one of the big things that kind of makes QR codes really pop out as QR codes. So as far as encoding the data and kind of what the information is, there's a couple different things that kind of go into it. The first is one thing that is pretty cool about QR codes is there's actually some like error correction built into the QR code, which is pretty cool. So essentially one of the parts of the QR code is actually an error correction mechanism. So part of the QR code can be damaged, but because of the error correction that's built in, it can, even if part of it's damaged, it can still give you the decoded result that you're supposed to get, even if part of it's damaged. Now, obviously, it depends on how big the QR code is and how much of the QR code got damaged. So obviously, your results may vary, but it's kind of similar to like error correcting memory on like computers, in a sense, where because the error correction bit can check if a bit flipped, it can then flip the bit back. That's essentially how error correction memory works. So QR codes are kind of similar in the sense that every so often there will be like essentially error correcting bits, if you will, that if some part of it's missing, because of the error correction built in, it can recreate that data that's missing. Now, obviously, like I mentioned, it's going to depend on how much of that data is missing. Obviously, if half the QR code's gone, you're probably not going to be able to recover that data. But if you have a pretty large QR code and a little slice of it's missing, yeah, you'll probably be able to recover that without too much issue. So another thing when it comes to QR codes, they can be made up of a maximum of 177 rows and 177 columns, which makes for a possible 31,329 data modules. But most QR codes obviously aren't that big. But yeah, they can encode essentially a good amount of data. So they can store up to 7,089 numerical characters, or 2,953 alphanumeric characters. So basically kind of what this means is that if you have any kind of like URLs are classic for QR codes, you can encode them easily in there, or really any kind of letters or numbers or anything you can fairly easily encode within a QR code. So some other things that people will encode in QR codes are like authentications for things like restaurants or hotels or websites, payments. There's a lot of different things that you can encode in these QR codes. Since, if you got 2,953 alphanumeric characters to work with, it's a good chunk of data that you can fit in there. Heck, if any of you really want to get fancy, and you're tasked with writing an essay or a paper or something like that, rather than submitting the paper, what you can do if you want to be cool is you can write the paper, convert it into a QR code, and just send your teacher or professor the QR code and be like, here's my essay. Now, I have to say, if I was ever in a situation where I had to grade papers, which I really hope I'm never in because that just sounds awful, but if I was ever in that situation and someone submitted me a QR code for their submission and I scanned it and that was their essay, I'd honestly, regardless of the content, how good the content was, I'd probably give them a baseline B just because of how cool it was. And then as long as their essay was semi good, easy A. Because if you go through the hassle of encoding that in a QR code and just submitting a QR code, we talk about the cool factor, right? We've mentioned it on the podcast before. If something looks cool, it automatically improves its performance, right? So with computers, if your computer looks cool, if you got the unicorn, vomit coming out of your PC with all the RGB lighting and everything, obviously that's easily an extra, what are we talking, 50% performance gain? We mentioned if you have wires on your desk from your keyboard and mouse, that's obviously going to detract at least 5 to 10% minimum from your computer's performance. Similar, we also talked about cars. If you have two identical cars, one's clean and one's dirty, obviously, without a doubt, the clean car is going to be at least 20% faster. So, obviously, looks play a huge role when it comes to performance. So, on a technical level, I guess, if this wasn't already technical enough, bringing this back to QR codes. So basically how the scanner, I guess if we're talking about your phone, works is it'll begin in the bottom right, and then it encounters the mode indicator, which, yeah, QR codes are kind of complex. There's a lot of stuff in them. So basically what the mode indicator does is it tells the scanner what type of data it's dealing with. So whether that's alphanumeric, numeric, that kind of thing. And then based on that bit, then it'll be able to decode the rest of the data accordingly. And then basically it kind of zigzags through the squares and kind of goes through, and then this is where the error correction is baked into it. So kind of in these segments, it goes through I'm not exactly sure how many it reads at a time, but it'll read so many blocks at a time going through a zigzag pattern. And then based off that, there'll be some error correction built into there. And then based off whatever that initial, what did I say was that initial data module indicator is, then it's able to zigzag through the QR code and decode the data accordingly. So yeah, I'll leave a link to a site that kind of goes through how it kind of works if you want to read a little more into it. But that's kind of nutshell, kind of how QR codes work. They're definitely super cool. Kind of underrated. I kind of think. I think it's one of those technologies that people just kind of take for granted. They just be like, "Ooh, QR code, cool," and then they scan it, and then the thing pops up on their phone, and then they click it or whatever. So definitely underrated for sure. But with that out of the way, let's get into what nerdy stuff have I been up to this week. So as I mentioned, I was turning into an absolute code monkey this week. So for the listener last week that I mentioned that gave the feature request or feature recommendation, I guess, where I should turn my my server that I made to basically count down how much time I have left in grad school, but make it just basically convert it to a universal countdown thing. Your feature request has been implemented. So for those of you who don't regularly check up on my GitHub, I posted some updates this week to that. I created a new repo called the Universal Countdown, and at first I just kind of implemented the client server thing. So basically how it works now is you'll have a server that'll read in a config file, and that config file will just have the year, day, hour, minute, and second, I believe, of when whatever event you're timing will happen. So, for example, if say you have I don't know, you're counting down till your birthday, let's say. You want to do a countdown for that. If your birthday is, say, on May 5th, let's say, you could do 2023 for the year, and then for the month you'd have 5 for May, and then for the day you'd have 5 since May 5th, and then I guess you could do 0 for the hour, and then 0 for the minute, and 0 for the second. Then based on that time, it'll then be able to send to the clients dynamically whatever that time is. And the other cool thing about it is I kind of went back and forth on how I wanted to implement the config file. But inevitably, I decided to just, every time you get a request, read the config file. And the reason I did it that way was, quite honestly, because I ran into a bug on my Docker container and on Linux where it just was not playing nice for whatever reason, which was weird because I tracked the input all the way through the program to the point where it knew darn well that the time was correct, but then when it would do the comparison, it would always say that the difference in time is 0 and the time is up, which was not right, which was weird because I literally tracked the timestamp that it had through the entire program to the point that it got to that comparison check, and only then did it decide to, be wrong. What's weird is that issue didn't happen if I just read the config file every single time. So, not exactly sure why that was the case, but that's inevitably why I decided to read the config file every time. Because part of me was like, that's a lot of file I/O that you have to do reading a config file every time. But at the same time, it's a multi-threaded server, so that's not necessarily a huge deal. But then I also figured, hey, this is not a bug. This is a feature, because you never have to turn the server off, because if you ever want to change, the event, all you got to do is change the config file and the server will just pull it automatically on the fly, so you never have to reboot the server to get the new time. So that's pretty cool. So in reality, this is not a bug. This is a feature for sure. Now, as far as the client aspect goes, the client also has a config file, and you're able to obviously specify the server's IP address and the port number. And the reason why I wanted specifically to specify the port number was so I could do various testing, because I only wanted to, because I was trying to get my Docker container working right, which it works, by the way. But as part of that, since my Docker host, I only have Docker really installed on one machine, and I didn't feel like installing it on a different machine just to do a test. So what I did was I implemented the ability to change the port number, which also I think that's kind of nice, being able to change the port number like that. Obviously the server, the only way that it changed the port number is to stop the server, change the port number, recompile it, but I mean, I kind of think that's a worthy trade-off, because once you start the server anyway, there's no point. You'd have to stop the server to change the port number anyway, because when the server is set up, it binds to that port number. So the only way to stop that is, I guess maybe you might be able to programmatically like kill the bind and then rebind, but that'd be kind of a hassle, so you might as well just start and stop the server. So if you're starting and stopping the server, it's not that much of an extra step to just change the port number in the actual server file. So I didn't feel like making that configurable. But on the client side, it is configurable, so I was able to test multiple servers on the same machine with different port numbers, and that worked fine. And then the other thing that the client has the ability to configure is what the occasion is, because I thought about having the server have the occasion configurable, but the problem with that is when you're sending data from a server to a client, specifically in C, which is what I wrote it in, you have to specify how much data you're going to send, which isn't necessarily a problem from the server end per se, although if you're reading it in from a config file, you never exactly know, but I mean, you could easily just get the string length and write that and you'd have no problem. The problem comes on the client side, because the client side, you need to know how much data to read, and if you don't set your buffer large enough, you're not going to get all the data from the message. So I kind of went back and forth on how I wanted to go about doing that, and what I inevitably decided to do was just say, whatever, we'll just have the client say whatever occasion they want for the occasion, and just let the client configure it, since that way you always know the message is going to be a set size and you don't have to worry about, am I reading enough data or not. So that's what I ended up deciding on doing, and I got those changes pushed, and then I decided to start work on the iOS side of things, making the iOS app. Now, the iOS version it's made, it works, and it's not a total hack job like the previous one that I made. So I'm guessing it was probably just because I was tired when I was trying to make the original one, but I pretty quickly figured out the issues I was having before, namely not being able to access the core data from like another class, which obviously I was just dumb, because it's pretty simple to do that. You just have a context variable inside the class that you can set in the initializer, and then you can pass through the core data object as a variable. So I don't know what the heck I was thinking, but then again, I guess in my defense, it was like 2 a.m. when I hacked it together. So, and I do know for a fact that I was definitely kind of glazed over at times when I was writing the original version. So I'm going to chalk that up to being tired, although if you want to chalk that up to just being an idiot, I don't blame you. But with that said, I did make it so I think personally it's pretty clean. Now, I am by no means an iOS expert when it comes to iOS development. I definitely would consider myself to be a novice when it comes to Swift, because how infrequently I program in it. But I think this app is it's really simple and basic, but at the same time, I think it's fairly decent. Now, is the UI a flaming hot pile of garbage and not attractive at all? Yeah, probably. But at the same time, as I've mentioned many times on this podcast, user interfaces is not my forte. I make them functional, and that's about it. Because if you look at the UI for this app, while it might not look the best, it gets the job done. It's functional. It tells you what data you need to know. It allows you to set the parameters you need to set. It does the job. And as just like the clients for Unix and Windows machines, there is a separate settings page where you can manually set the IP address, port number, and occasion for your whatever your countdown is. So that's basically the same. The only, I guess, big difference with the iOS app is because it uses core data, it's able to show you the last time that you updated. So it's basically able to show you the last timestamp and whatever the last time it checked in with the server was, regardless of if you have internet access or not. So that's pretty cool. And it also gives you the option to just press an update button rather than having to rerun the program every time. So I guess that's another cool thing. But the one thing that I'm kind of really proud about with the app that I had never done before was adding like the quick actions. So if you're not familiar with what quick actions are, it's that thing on iOS where if you it used to be 3D touch, but Apple killed 3D touch. So if you long press on an app and you kind of get that like little context menu where it'll have like share app, remove app, and then like maybe has some other options. I added two options in there. One automatically updates. So basically if you hold down on the app and you hit that update option, it'll open the app like normal, but also update when it opens the app. Since normally what happens is if you open the app, it doesn't actually update. You actually have to press the update button. So doing that quick action will automatically do the update for you. And then the other one is it just takes you straight to the settings page. So you don't have to press an additional button when you open the app because that's way too much effort pressing an additional button. Now, I guess arguably you probably don't save any time because the time it takes for you to long press on the app, have the context menu pop up, and select the settings thing, arguably you could say that takes just as long, if not longer, than opening the app normally and pressing the settings icon. But, as someone trying to improve their iOS skills, having a feature like that, even with how stupid it is, I guess, it kind of helps you learn and that kind of thing. Which, one thing that I was talking to actually a listener of the show about when this kind of came up, the same listener that made the feature recommendation. They in the same vein when they were talking, giving the suggestion of making it universal. They made the comment that maybe I should, work on Swift more and, basically write more iOS apps. And I want to, but the problem is how much of a pain it is to use iOS apps that I make because I'm not an Apple developer. And if you're unaware, Apple requires you to pay $100 a year. Okay, it's $99, but basically $100. $100 a year to be an Apple developer, and basically the perks that gives you is it allows you to put apps on the App Store. So if you're not an Apple developer, you don't have that paid subscription, you can't put apps on the App Store, which isn't a problem. You can still develop iOS apps, but the problem is because you're not an Apple developer, the length of time that you can sign apps to your iOS devices is limited. I think it's like a week. So literally, if you want to use an app that isn't on the App Store and you're not a developer, you have to re-sign that app to your phone. every single week if you want to keep using it, which to me it's just kind of a hassle, right? Like, I personally, I've never really, like, I've written a few iOS apps. This one, I guess that hacked version I did before, the Snapchat database app, and then I made an app that basically converted my personal website into an iOS app. But, like, none of those apps I really feel like had enough utility to make me want to use it all the time. And the other problem too, because, you know, you're unable to use it after a week. I mean, it's just such a hassle to have to re-sign it all the time, which I know this is like a huge, just, you know, first world problem, but it's just kind of a pain and kind of a nuisance. And I personally don't feel like spending $100 a year to put apps on the App Store, especially like apps like this that are like super basic and don't have necessarily a ton of functionality. Since, well, I guess you could argue, you know, the Snapchat database app is functional and would be useful. At the same time, the only way that you can like actually use it is to manually enter the data. Like, it doesn't sync with any kind of like Snapchat APIs or anything like that to dynamically add stuff to it. So in that sense, like, it's all on you to use the app. And then my website that I converted into an app, I don't really, I don't, you know, go to my website all the time, and like, I wouldn't use that app really at all anyway. So it was just kind of, you know, a fun project to do to essentially convert my website into an iOS app. And then this one is actually functional. But at the same time, you basically have to have your own server running to be able to connect to it in the first place. So in that sense, I don't really see much versatility of it being on the App Store. I mean, if people wanted me to, if there was like enough interest to like actually have one of the apps I made on the App Store, I'd consider putting it on there. But it's one of those things that, like, at least right now, there's literally zero return on investment for me personally, because I wouldn't charge any money for these apps, and I wouldn't have any kind of in-app purchases or anything like that. So obviously everything would be free, so I wouldn't make any money off of it. And personally, I don't really feel like spending $100 for a year for something that would essentially, basically something that no one would use. Now, if I heard back from a lot of people, say on this Universal Countdown iOS app, for example, that a lot of people used it and liked it and were kind of annoyed that they had to reinstall it on their phone every week, then I'd consider, you know, getting the license and putting it on the App Store. Or if I make an app in the future for something else, and I get feedback from people that they really like it but kind of wish it was on the App Store, then, you know, I'd consider doing it. Or if sometime down the line so basically, I guess, this tangent aside, what it comes down to is, I'm not saying I'm never going to be like a subscribed Apple developer and put apps on the App Store. I just personally don't see myself doing it anytime in the near future. Essentially, I guess that's what it boils down to. So that was quite the tangent. I didn't expect to go off on that kind of a side tangent. But do you guys remember the distributed compiler, the dynamic cluster compiler that I was working on, that I've talked about for weeks now, that seemed to has essentially stalled out and been completely neglected like all my other projects? Well, if you don't follow the Dark Assassins Inc. on Facebook or LinkedIn, you might not be aware, but I finally did get that out the door. So we had, I guess, 2, or I guess you could argue 3 software releases this week. So yeah, that's why when I said I basically turned into a complete code monkey this week and just went ham on coding, that's basically what happened. You know, I converted a server, technically 2 clients, an iOS app, which I guess you could argue is a client anyway, so that'd be 3 clients, and then this dynamic cluster compiler. Also got that out the door. So it was a very hectic and busy week for me. Lots of coding, lots of tinkering. But the cluster compiler, I added a few more examples. I actually added the server program from the Universal Countdown. I added that as one of the examples for Unix machines, because obviously there's no sense in having it as an example for Windows because you can't compile it for Windows, so I didn't add it there. But so Unix systems currently has 3 examples up on my GitHub, and Unix has 4 examples rather, and Windows has 3. So one thing you'll notice is if you do go check out that repo, you'll notice that there's essentially, aside from that universal compiler, which I called multiple DIRs as the folder, because at the time none of the other examples had multiple directories in it, so I just called it multiple DIRs as an example. But that's the universal compiler, or not universal compiler, universal countdown rather. So where was I going with this? Oh yeah, so you'll see that, like, there's a hello world in each the Unix and Windows. There's a Java example in both the Unix and Windows, and there's a binary search tree in both Unix and Windows. Now, just so you're aware as the listener, the code is the same on both Unix and Windows. The only difference is a couple of the config files that's used for the compiler itself. Now, I thought about having just the source code there and then separate folders for the config files, one for Windows and one for Unix-based systems. But I wanted it to be as turnkey as possible, and having that situation where you had essentially 2 variations of the same config file, one for Windows and one for Linux, you would only be able to you couldn't have it turnkey for whatever cluster you were trying to compile for, right? So if you were trying to compile for a Windows cluster, which, by the way, I do not recommend, because at least in my personal experience, Ansible with Windows is insanely slow. So your compile times are going to be super long. But if you want to, knock yourself out. It's still cool to, compile across a cluster of nodes. But anyway, the problem with having, 2 different folders for the config files is it wouldn't be turnkey, essentially. Like, you'd have to do some more file modification than what you already have to do in order to get things off the ground, because the distributed config file that's used to launch, essentially tell the compiler where all the other files are and what cluster it's compiling for and all that jazz. Currently, right now, you don't have to change that file at all. Whereas otherwise, you'd have to specifically modify, and if you wanted to compile it for Windows, you'd have to change it to Windows, or maybe you'd have to change it to Linux or Mac OS, or whatever. But now the only thing you have to change is stuff specifically related to your cluster, right? Like, obviously, I can't program a config file for your cluster that'll also work for Bob's cluster, that'll also work for Alice's cluster, that'll also work for Zach's cluster, right? Like, everyone's cluster is going to be different. Everyone's network's built differently. Everyone's code's stored on a separate location. So I can't write a config file that will work for everyone. So the point of the config files in the config directory in each one is to basically tell what the IP addresses of your hosts are and where the source code is located. So in addition to doing that, like, literally that's all you'd have to change is those config files of the nodes in your cluster and where the source code is located. Whereas if I did it the other way and put, only had one instance of each one of the examples, but had like 2 versions of the config files, you'd have to do a little more changing, and it wouldn't necessarily be like turnkey right away. Whereas now you could literally download the examples, throw them on like a NAS, for example, and then as long as you adjusted the IP addresses for your hosts and the location where the source code is to match where it is for you, you could literally just run that right away and be good to go. You wouldn't have to worry about modifying anything else, which is why I personally wanted to segregate them that way. So I guess you could argue it takes up more space, but I'm pretty sure GitHub's got plenty of storage space for my few, I don't know. Actually, I don't know how many kilobytes it's taking up on GitHub, but regardless, it pales in comparison to a lot of other projects. But I wanted to try to make it as turnkey as possible for people if they wanted to check it out. So if you do want to check it out and you got a cluster of nodes, or you just have 2 computers that have the same operating system and you want to give this a shot, you can go ahead and give that a look. So that is the dynamic cluster compiler that is finally out the door. So now I can, I guess, focus on maybe some other personal projects that I've neglected. But one thing that I have not neglected is forgetting this week's trivia question. So if you'll recall, this week's trivia question is, when was the first multi-core processor introduced? So again, when was the first CPU that had more than one CPU, I guess, more than one core introduced? Now, if you said 2001, you are correct. And bonus points to any of you who said it was created by IBM with their Power 4 architecture. So round of applause for all of you who got this week's trivia question correct. And for that, I think that's going to do it for this week's episode. If you enjoyed this episode, I ask that you leave it a rating and review, and subscribe to the Dark Assassins podcast if you haven't done so already. Also, be sure to share with a friend or family member who you think would enjoy this episode. And if you have any questions about this episode, or you have any questions or comments for future episodes, you can shoot me an email at contact@darkassassinsinc.com. You can always click the link down in the show notes below for that. And that's going to do it for me in this episode of the Dark Assassins podcast. Until next time, my fellow assassins, remember, bool nothing equals true. If action not equal to null, return true. I'll see you next time on the Dark Assassins podcast.